Okay, question 2. So some food colourings are a mixture of soluble coloured substances. Mixtures of soluble substances can be separated by paper chromatography. So I'm going to highlight soluble just to remind myself of that during the question. So paper chromatography was used to try to separate the coloured substances in 5 food colourings, B, W, X, Y and Z. Figure 3 shows the spots of the 5 food colourings on the chromatography paper at the start of the experiment. The paper was placed in a beaker with the bottom of the paper in the solvent. So here's my solvent. I might just shade that so I know. Okay, so there's my solvent. So identify the stationary phase in this experiment. So the stationary phase, there's a couple of answers that I could have here. I could either write the paper itself, or I could put the water which is in the paper. Okay, but I'm just going to put paper. That would give me my answer. So give a reason why the spots of the food colourings must be above the level of the solvent when the paper is placed in the solvent. Okay, so why am I putting my dots below this solvent level at the start? Well, it's really because if I had the dots below and they ended up in the solvent at the start, they would just mix into the solvent. So it is to stop the dots running or mixing in the solvent. Okay, part 3. Figure 4 shows the chromatogram at the end of the experiment. So here's my solvent front, so that the solvent has run all the way up the paper to this point here. Here was my start line. So give the reason why the spot food colouring V has not moved during the chromatography experiment. Now they've actually given me that at the beginning because they've told me that mixtures of soluble substances can be separated by paper chromatography, because what happens is the dot dissolves in the solvent and then passes up the paper as the solvent moves. So that means that V must be insoluble. So V is insoluble. Explain. Okay, so this is an explain question. So I'm going to need to give a point and an explanation. By referring to figure 4, so I have to use figure 4, which food colouring contained the greatest number of soluble coloured substances? So the greatest number here, W's got 1, X has got 2, Y's got 3, Z's got 4. So the food colouring with the greatest is Z, that's my point. And what is my explanation? It has the most dots. Okay, part 5. One coloured substance in food colouring X moved 5.8 centimetres when the solvent front moved 6.6 centimetres. Calculate the RF value for this substance, giving your answer to 2 significant figures. Okay, so the RF value is always the distance that your substance moved divided by the distance that the solvent moved. Okay, so my solvent moved 6.6 centimetres and my substance moved 5.8 centimetres. So if I pop those numbers into my calculator, I get the number 0.878787 reoccurring. But I need to give my answer to 2 significant figures. So I'm going to take my first 2 numbers, but I'm going to check my third number just to see if it's number over 5, which it is. So that means that I have to round up my second value. So my answer is going to be 0.88. Now if I go on to section B, a food colouring has a molecular formula C16H12N2O. Calculate the number of moles of this food colouring in a 0.5 gram sample. Okay, so to calculate the number of moles, okay, I know that I have to have the mass of my substance divided by its formula mass. Okay, so I'm going to work out, I know the mass already, they've told me it's 0.5 grams, okay, but I don't know my formula mass, so I'm going to work that out. So they're giving me the relative atomic masses for each atom. So hydrogen's a 1, carbons are 12, nitrogen 14 and oxygen is 16. So let's add those up together. So I will have 16 times 12 plus 12 times 1 plus N is 14, 14 times 2 plus O, which is 16. Okay, so if I add those up, I end up with 248. And again, just pop those into your calculator. So now I can put my 248 into my equation. So I have 0.5 divided by 248, and that gives me an answer of 0.002. So I have 0.002 moles. Okay, and the final part to this question, part 2, calculate the number of molecules in 2 moles of the food colouring C16H12N2O. And they've given me Avogadro's constant, which is 6.02 times 10 to the 23. Now, that's just me understanding what Avogadro's constant means. That is the number of molecules that are present in 1 mole. So that's what it means. So 6.02 times 10 to the 23 is 1 mole, and if I want to have 2 moles, all I have to do is multiply that by 2, and that gives me an answer of 1.2 times 10 to the 24. And again, you can enter that into your calculator.